Welcome to this detailed tutorial on debugging Kafka streams. If you're working with streaming data applications, you know just how critical it is to efficiently troubleshoot and debug your applications. In this video, we're going to take a comprehensive look at various methods for identifying and fixing issues within Kafka Streams applications. To set the stage, let's first understand what Kafka Streams is. Kafka Streams is a Java library that allows you to process and analyze data stored in Kafka. It enables real-time stream processing and creates applications that can respond to events dynamically. Before diving into debugging, it's important to understand the common sources of errors in Kafka Streams applications. These can include deserialization issues, incorrect logic in your processing functions, or connectivity problems with your Kafka brokers. Keep these in mind as we explore debugging strategies. Let's kick off our debugging journey with the first method, using loggers. Logging is one of the most fundamental tools for debugging applications. In Kafka Streams, you can leverage SLF4J, which allows you to log vital information as your application runs. In your Kafka Streams application, make sure to log pertinent events. For example, log the data being processed, any transformations applied, and any errors caught during processing. This will provide you with a clear trail of what your application is doing and where things may be going wrong. Next, let's look at debugging with Stream Processor API. Kafka Streams provides an extensive API that allows developers to tap into the processing flow. By implementing the processor interface, we can add custom debug information to our processing. By integrating logging right into your processor logic, you can track the internal application state in detail. This granularity can help pinpoint where errors occur, especially in complex processing scenarios. Another effective troubleshooting technique is utilizing application state stores. State stores allow you to keep local state information in your stream processing application. They enable you to store and query process data, making it easier to analyze issues. In case of issues, you can inspect the contents of your state stores to understand what data was processed. This examination can provide insights into your application's behavior over time. Debugging issues with serialization can also be a challenge. If your application isn't processing records as expected, it could be due to deserialization failures. Make sure you are using appropriate SERDA for your data types. If you catch exceptions related to deserialization, be sure to log these failures. Kafka Streams provides a specific exception for this, deserialization exception, which you should capture adequately. When running your application, consider using the Kafka Streams built-in metrics. Kafka Streams applications expose various metrics through JMX, which can be a goldmine of information. These metrics allow you to monitor throughput, latency, and error counts, among others. You can visualize these metrics using tools like JConsole or Grafana to track the performance and identify potential bottlenecks in your application. Another important aspect is exception handling in your streaming topology. It's essential to set proper exception handling strategies. Using a deserialization exception handler or a custom error handler allows you to control what happens when your application encounters issues. Let's talk about unit testing your Kafka Streams applications. Unit tests can help eliminate bugs early in the development phase. Kafka provides a Streams test driver which allows you to test your stream processing logic without needing a running instance of Kafka. Unit tests can confirm that your processing behaves as expected and help you catch issues before deploying to production. Define various scenarios and assert the outcomes to ensure your logic is correct. Moreover, integration testing can further validate how your components interact. This often involves starting a local embedded Kafka server to test the full application's flow. To wrap up, don't forget to recheck your configurations. Sometimes, seemingly small misconfigurations can lead to significant issues, particularly with properties related to the state stores and consumer group settings. Always validate your complete configuration before running the application. Misconfigurations can result in timeouts and connectivity issues, or might even lead to application crashes. In conclusion, debugging Kafka Streams applications requires a combination of logging, metrics, and testing methodologies. Use these strategies systematically to troubleshoot and optimize your applications effectively. Thank you for watching this tutorial. If you found this information helpful, please like and subscribe for more Java programming content. Leave your comments or questions below, and happy debugging!